Good afternoon, everyone, and welcome to the first of a series of seminars given in cooperation with the VIB Bioinformatics Core, Elixir Belgium, and the fledgling Belgian Research Software Engineers Society. The first speaker is Dr. Matthias Stahl. He is a data visualization specialist who owns his own company called Hish, and is also a part-time bioinformatics researcher at the Karolinska Institute in Sweden. Thank you very, very much, Matthias, for joining us today, and look forward to hearing what you have to say.
Yeah, hello everyone. Nice to meet you in Belgium. So I'm actually located in Germany right now, but I'm working for Karolinska Institute in Stockholm, which runs quite easy in these times online. And I'm also owning, as James said, my own company, Hish, where I do data visualization. And with that, I want to switch to my slides. And so I just turn on the screen sharing right now. And let's see. So now you should see my slides. So today will be about compelling data visualization with D3. And before we go into the coding stuff, I want to tell you that the web basically is the best home for your data visualizations. So maybe you're working with R or you're working with Python in your daily work. And there you also have visualization libraries, of course. But when you want to show your research output, your visualizations to someone else, let it be your cooperation partners, let it be the readers of your papers, or just a public audience, then the web is really the best publication medium, because everyone has a browser installed, everyone can just open a web page, and you can keep this web page up to date through the internet, of course, and your browser is a really cool machine. It enables a lot of cool software stuff. And when it comes to the web and visualization, then there are a lot of different JavaScript libraries that you can use, because JavaScript is the language of the web, at least of the interactive web. But there is one JavaScript library which really sticks out, and this is D3, the data-driven documents. And D3 is a very low-level library, so it makes it possible for you to put shapes on your screen. It makes it possible for you to transition between different states of your visualizations. It makes it possible to include scales to your visualizations. This is one thing we are going to look a little bit deeper in a second. And you have other mathematical tools like interpolations, or when it comes to the browser, you are also able to do DOM manipulation with D3. So DOM is the document object model. This is basically the tree structure of the elements on a web page. And this is all enabled by D3. So in the preparation for this talk, I thought about, well, which concepts do I want to explain and how to explain that? And then I thought maybe it's easiest to just build something with D3 live here on the stream. So that you can see how all these concepts of D3 actually work. And yeah, so let's just go over and build some stuff. And usually when I do a new data visualization for someone, may it be a client for my own company or may it some research project for Karolinska Institute, I always take a blank piece of paper and a pen, and then I just draw the stuff I want to visualize. And for today's session, I thought about, let's take something a little bit scientific, but not too specialized. So I'm working at a subsection at Karolinska Institute, which is called Science for Life Laboratory, or the SciLife Lab. And they have a data center, and this data center can provide you with all the recent publications that were done by groups at SciLife Lab. So I thought maybe we could just visualize the number of different publications across recent years from 2010 to 2020, and then split this area chart in different sub-areas by the journals where these papers were published. So for example, that we have like, I don't know, here 10 papers published in journal A, and so on. So that we get this nice area chart with these multiple areas on top of it, and this is called a stream graph in the DataVis language. And this is not so easy to do with a higher level graphics library also. So here you need to use D3 to make it, to tailor it to your needs. So this is what we want to do today. So and for that, let me just switch to my code editor. That's that one here. And I want to show you my basic setup for a data visualization on the web. You don't have to note down anything of that. In the end, I will share a GitHub repository where you can easily download this starter pack here and code your own visualization on top of it. Or you can also download our final visualization that we are going to build today. So what I have is I have here a data folder. And in this data folder, I have a CSV file which just holds all the different publications that were done by SciLife Lab researchers in the last 10 years. In every row, there's a new publication with the title, authors, the journal was in, the year when it was published, and so on. So this is publicly available data. And maybe it's a nice exercise afterwards for you to just use the publication data of your own institute. Then I have this source folder here, and some of you that are more familiar with the web languages know that the index.html is most of the starting page for any web page that you publish on the web. So let's just have a look at that. And an HTML web page consists of a head where you specify some meta variables, where you can specify a title that is shown later on the tab of the browser, and so on. But the more important part for us today is the body part of this HTML. And here I have already put a title, which is the SciLife Lab publications, and the subtitle. And then I have this div element here with an ID of this. So this is the most important stuff we are going to look at today. And I can run this project already in the browser. This is also explained how it's going on the GitHub repository when you go to it later. So when I just go to the browser and go to my web page here, I just see SciLife Lab publications. This is why my H1 title and the subtitle for the visualization. And here on the bottom, we will get our visualization. So if I go to the developer tools in Firefox, I have my inspector here, and I can see the different parts of the web page, and they also get marked. You see here is the title, the subtitle, and this is this div element with ID vis, where we want to put our visualization in. So this is just a basic HTML markup that we need to get started. And of course, you can put such a basic markup in a template GitHub repo and reuse it every time you want to build something. So now every time I change something now in the code, this web view will get updated, and we can see the effect of what we have built directly here in the browser. So let's go back to the code editor. And what I have here in the source folder is another folder which is called scripts. And there I have my index.js. So this is the starting JavaScript file. And I just want to show you the first couple of lines that I prepared for today's talk and quickly explain this to you. So the first line is just importing some styles. So you can omit that. It's just that the title looks a little bit nicer. And then this is very important here. We import everything from the D3 library as D3 variables. So I import all the functions that D3 provides to us that we are going to use later on. I import them all and put them in a variable D3. From there, I can call them. And then I also import another file, which is called journals. And we're going to have a quick look later on that file, what is in there. And then in the next lines here, we have here the data read in. So that means D3 provides me a function which is called CSV. And with that function, I can read in all the data I want to have. In that case, it's just this scilab publications.csv file, and then I can do some formatting on it. And then here I do some reordering, restructuring of the file so that you get all the publications for each year. I won't go into much detail here, so you can have a look at that, what that is doing after the talk, and you always can ask me questions, of course, afterwards. This is a little bit too much JavaScript for now and too less visualization. This is just reordering our data file. And then in the end, we create our database with that function where we pass in the data, and that is that function here on the bottom where we will write now our visualization in. So this is the basic setup, and yeah, from now on we are going to program our visualization. And the first line of code here in this create vis function is really nice because it just shows the capabilities of D3. So here we take again D3, and now we use the function select and pass in the ID of that div element we had in the index HTML, if you remember. So here we had this div ID with, and now we just target that element because here we want to put our visualization in. And that just shows you that D3 is able to handle document object model elements, so DOM elements. With this D3, we can select any element. D3.select, we can select any element that we want on our page. And that is then stored in the variable vis here. And then we can also access this element when we call vis.node. So this gives us the actual properties of that DOM element. And for almost all HTML elements, there is a function which is called getBoundingClientRec that just gives us some idea about the dimensions of that div. So we are pulling out the width and the height. And at that line of code, I just want to make a short pause because many of you might not be familiar with JavaScript. And JavaScript, usually there is half of the audience really loving it and half of the audience really hating it. And it's usually quite hard to convince someone that JavaScript is really a nice language. For me, it took, I don't know, 2 or 3 years that I believed, okay, JavaScript is really cool. And nowadays, I think that JavaScript is the perfect language for the web. And but it comes with some very weird syntaxes and functions. And this one here, which is called object destructuring, is one of those. So this with node get bounding client rec gives us width, height, but also much more properties of that node. For example, also the top and left positions and so on. And if we want only pull out some of these properties, we use this object destructuring syntax here so that the width and the height get stored in the respective variables. And then we also construct an object which is called margin. And it has property V for vertical and H for horizontal, 50-50. This is just the pixels of the margins that we want to put on our visualization later on. And usually it's a good idea when you start coding, especially in D3, which is a very imperative language style. It's really good to just put in comments what you want to do. And I want to do this now together with you. So usually the first thing you do when you design a visualization with D3 is that you make sure that your target elements, our vis here, is really empty so that there's nothing in. So let's just say delete everything which is in the vis variable so that there are no remaining elements from a previous page load or from the browser cache in there. And then almost always the second thing you do in visualization programming with D3 is that you define your scales. And if you remember, we have this area chart, and this area chart has an x-axis. So we need to somewhat define an x-axis, and we need to define a y-axis, which would be the number of publications. So these are the so-called scales of D3, and a scale is nothing else than a mapping between actual data points and pixels on your screen. So you can imagine that, for example, the year 2010 that we want to put on the very left on the page has some small pixel values, if I count the width, and the higher years like 2009, 2020, they should end up on the right on the page. And this is really, you see that this is really a low-level library here. So we have to make sure that everything ends up on the right, at the right coordinates on the page. And then when we have defined our scales, we can also define a function which takes our data and changes this data somewhat so that we get this data structure for the area chart or for this stream graph. So this is the stacked area chart. So we somewhat need like a stack layout. And maybe it's here also a good idea to just also show you how that's working. If we build the stack layout here at the beginning already, then it's maybe a little bit lighter to imagine what the scales really do. And after we have done that, we need a so-called path generator, because everything D3 actually does is it's generating elements that are put into the DOM so that it can be interpreted by the browser. And there are certain elements that you can generate. Usually we are talking here about an SVG, a scalable vector graphic. And a scalable vector graphic can have, for example, circles, it can have rectangles, it can have all types of shades, for example, and other effects, but it can also have paths. And paths are basically lines, and you can decide programmatically how these paths look like. And I want to build the stacked area chart today as an assembly of multiple paths. So we need a path generator, and a path generator is a JavaScript function which takes the data we have generated and outputs the path coordinates. And yeah, if we have done that, we have everything together to actually plot stuff. So we should create an SVG. So that is the actual graphic that we put on the web page. And then we can add the paths to the SVG. And if we have some time left, we can also label the axes so that we know what are the years, what are the number of publications, and so on. So this is what we are going to do now. And yeah, so let's first delete everything which is in the this variable. And here I can use again another trick from D3. So I can just say with.select all. Oops. With.select all, and then I can just say really I take every element which is within the this container, and I can just execute this remove function on it, and that will just delete everything which is in our this element. And if we go to the browser, we can see, okay, this is our this element. It's really empty now. Admittedly, it was empty before, but you never know what happens in browsers. So it's really important to put that statement here. Otherwise, you are debugging for hours later on when something is not working. Okay, and now we are defining our stack layout. And this stack layout, I said it before, is just a function which is taking our data. And now I talked a lot about our data. Let's actually first have a look how the data looks like. So we got our data here in the data variable, and we can just console log data, and this console log statement will just print the data here to the console. There's a lot of errors going on, so don't get distracted by that. But here it says array with 11 entries, and you see here that these 11 entries are all objects, and you can see there's a property year, which is 2020 for the first one. And then if I open that, we can see year 2020. And then this here is actually the identifiers of 10 different journals, which are the top 10 journals where SciLife Lab researchers published their papers. And you can see here the numbers behind. So that just means in that particular journal here, which has this unique identifier, there were 15 publications in the year 2020. So this is our data structure. And this goes on here for all the other years down to 2010. So this is how our data looks like. And now we want, for the stack layout, we want a function which takes the data and transforms it in a way that it can easily be plotted later on to the screen. Now I show you that, so we can make just a new variable. Let's call that stream, because it will be a stream layout, a stream graph in the end. And we use, again, D3, and it comes with a function stack, which is a base function that we can already use, but we can also customize it a little bit by calling more functions on that. And there's a keys function where we can specify what are later on the keys. So what should be these separate sub areas? And I told you before, we want to have that split up by the different journals. So we can tell now D3, hey, look at these certain journal identifiers. These should be the keys. So now I could extract these journal identifiers from the data, but to make it a little bit easier, I created this file journals.js, and there I just have an array, which is marked by the square bracket here, and in this array I have objects, which are marked by the curly brackets, and every object represents one of the top 10 journals. So there is, for example, +1, which has this unique identifier here, and I also already selected a color that we can color it easily later on. And I can import that file. So I did that here in the beginning, import journals from the journals file, so that I have a journals array. And I can now take this journals array. And now, attention, now we are doing very nice JavaScript functionalities. Arrays are very common data structure in JavaScript, and there is a lot of built-in methods. There is also a method which is called map. And we give that map function a so-called callback function, and we can say, okay, run through all these journal objects and put all these journal objects in the variable j at the time you are there, and then go to the journal object and take the ISSN, which is this unique identifier, and give it back to me. So this function here will just extract all the journal ISSNs and put them in a new array. So just for now, I just take that and do a console log. And we can see here we get an array which has just these journal ISSNs as entry. So here we just get all the identifiers of the journals. This is what this map function does. And this is often the reason why people are hating JavaScript, because we work a lot with these callback functions. So this is a function taking j as an argument and then running j.issn, and map means that this function is run on every single object within that journals variable. And this is something which is maybe quite hard to get your head around, but this is something you just need to exercise if you like doing more JavaScript. And in the end, it's a really cool thing when you have your head around that. And then this one, so this assignment here will give us a function, and we can directly run our data through that function. So we can just invoke that and put our data in. And to just see what happens here, we can console log the new data structure. So here we get now an array with 10 entries, which should be our top 10 journals. And I just open one of these entries, which is again an array. And you can see here that we get in total 11 tuple arrays. So 11 arrays for each year from 2010 to 2020, we get one of these arrays. And this is just specifying a position on screen, which means, okay, for this journal, in that year, there was maybe only one publication. So this specifies my y-axis now. So go from coordinate system y0 to 1. For the next year, this area should go from 0 to 16 and so on. So this is basically specifying one of my areas. And this is true for the other journals too. So here we start at 0 because that's just a, let me go to my slideshow. So this is just the bottom area here. It starts at y0 and then goes to some variable y here. And then for the next journal, of course, this is dependent on how the bottom area looks like. So here we start at 1, go to 11, and so on. This is not pixels yet. This is just in a random coordinate space that D3 calculated for us. But it's all relative to each other, so we can work with that already. And this is just reshaping our data structure. That's everything we did with this D3 stack statement. Yeah, and now we are basically ready to define our scales. So first of all, we have our X scale. So the scales, as I said before, are again functions, JavaScript functions that are able now to take these random coordinate system numbers that I just showed you and really translate them into pixels on our screen. And now you have to think about that a little bit more. Screen is the screen that you might have on your computer is not the screen that others might have on their computer, or even when you think about small iPads or mobile phones, you have completely different screen dimensions. And this is why we pull the dimensions here directly out of our target width node. So this width and this height will be really user specific. So if you run that on a mobile phone, for example, the width and height will be completely different. And now we need to map from our constant coordinate space that we get here in our stream data object to these variable screen dimensions. And therefore we need the X scale and the Y scale. And D3 comes again with some predefined functions. For example, this scale linear function, which is able to do a linear interpolation between your coordinate system and the screen. Screen coordinates to the pixels, basically. And for all these scale functions, you need to define the domain, which is actually the random coordinate system. And you need to define the range, which is the pixels on the screen. So here for the X scale, this is basically the years between 2010 and 2020. So what I could do is I could just write here 2010 to 2020 as an array data structure. That's possible. But now if you want to update that with new data next year, you would have to change the code to 21 here. That is not very nice. So let's not do this. Let's grab these two extreme values directly from our data. And therefore, we have a function d3 extend. And d3 extend basically can take the data. And now we don't want the data at all to have the domain. We just want the years. And if you remember, we have this nice map function again. So we could pull out the years by just saying, okay, store every datum here in the D when you run through all these objects. And then we access the year so that we get an array where only the years are in. And this array with the years, we pass into the extend function, and the extend function just determines what are the minimum and maximum values so that we will get this 2010 to 2020 array. We can do another trick here. We can not only give us back the year, but we can give us back here plus the year. And this is a JavaScript shorthand for transforming that string, maybe, which is in the year, to a numeric value. And then we have to specify, so the years 2010 to 2020, where should they end up on the screen? And we have to provide an array here. And if you think about that, we could say, okay, from 0 on the left, because the screen coordinate system starts at 0, 0 at the top left corner, and then it runs to the width here on the right and to the height here on the bottom. So we could just say this should go from 0 to width. But actually you want to have a little bit of a margin left and right. So what we should do here, and this is a convention in D3, which you should use, is that we start at the horizontal margin that we set above. This is where it is 50 pixels here. And we don't run straight through the full width, but we just subtract the horizontal margin from there. And this will be then our range as screen pixels. So here the years are then translated into the range. And what can I do later is that I can, for example, say X scale is my function, and I want the year 2015 maybe, and this will give me back the pixels. Let's have a look at that. So if I console log that, and we go to the browser, and let's have the semicolon here that it doesn't complain too much. So here we get the 567, and this is the pixel position where the year 2015 should be put later on. And now you can see when I change the width of the screen and I reload this page, we get 637.5. So this is a completely different value because the width changed and the X scale function is redefined with the new width, and so we get an appropriate scale for all of the different screen width that we might encounter. Okay, now let's do the same thing for the y-axis. So the y-axis is the number of publications and that we have. Now the thing is that we actually don't know what our y values are. So let me just make a helper variable, which I call all y values, where we collect all the possible y values that we might have. And we already created that stream variable where these y values are in. You remember these two-member arrays. And from there, we want to extract now all the possible y values that we could have. And of course, we have an array, so we can again use the map functionality, the map method of that array. And of course, we will again have this callback structure here. So for every object we run there, this object will be stored in D. And now let's access D. And if you remember, let me just have a look again at the actual data. So the stream was if I access one of these entries in the array. This is itself again an array of all these duplicate values here. So what I can do is I take that D, which is again an array, and I can run again a map function on that. And then I get another D, and this D then is actually, yeah, now we can't see this anymore. This D is, so we access that, and then we access that, and this is again this two-member array, and we want to have the 0 and the 1 later on as a separate value. So what we can do is we can create a new array with the 0 and the 1, so we access these array elements directly, and this will give us all the y values, and they will be in a nested array later on, so we can just call this flat function with the option 2, which just makes one array out of that. So this looks quite complicated. So let's look if we did that right at least. So let's console log all the y values. And what you see here, we get 220 values now in one array. And there are all the different possible y values now in. So basically our y-axis needs to span from the lowest possible value here to the highest possible value here. And then we would have a dynamically adjusted y-axis. So let's define now the y-scale. And again, we use D3 scale linear. And here, just to give you a little bit an overview of all the functions, you can also use scale log, which will give you a log function. For example, if you want to have a log scale on the y-axis, makes no sense here, but just that you see what is possible. So we want a linear axis, and we need to, of course, specify a domain again, and we need to specify a range again. And our domain now will be, again, the whole extent of all the y values. So we can just say all y values here, from the minimum to the maximum y value. Well, that's a tongue twister. And then for the range now, we want to go basically from the height, because the lowest possible number of publications should be at the bottom of the page. And as I told you before, our coordinate system on the screen runs from 0 on the top to the height on the bottom. So we want to start at the height and go up to the top, which is 0. And again, here we should by convention use margins. So we don't want to start at the very end of the screen. So we should subtract a margin vertical here. And here we should add a margin vertical, so that we have some margin on top and at the bottom. And this will be our Y scale. All right. So now we have basically all the scaling ingredients, and we also transformed our data to a format where it's easy to plot for D3. And now we are moving on to the path generator. And the path generator basically will take our stream data and also use the scales to map the stream data to actual path coordinates. And yeah, how these path coordinates look like, we will see then later on when we put it to the SVG. But for now, let's just program that path generator, and we can call that like stack area, because that is actually plotting one of these areas. So for each of the journals, we want to have one of these areas here. So this stack area function that we create here uses again D3, and there is an area function. And the area function is the base function for all the different path generators to produce area charts. And we need to tell this function what the x and y variables actually are. So there's a method.x, and we can say as a callback again that every data point which comes in, for this data point, you should take the x scale, because that is on the x-axis. That is a little bit too much here. So we should take the x scale, and within this x scale we put the actual year, and that year is stored in d.data.year. Why that? So let's have a look again on the stream data object that we have. So here, for each of these elements, we have the y values here. And yeah, yes, these are the y values. And on the fly, D3 will create this data object on it, which will hold then all the additional information, like the year from which that was taken. So you see that here. If I go to the actual data point, so this is for the first year, for 2010, for this journal, the first y coordinates. So it goes from 0 to 1 on the y-axis, and there it has all the metadata in that data object, which has also the year. So here you know that this is from 2020. I know this is quite nested, but if you are used to work with D3 for a longer time, maybe you get used to that. So this is our x, and then we want to have our y values. And of course, here we have our area chart. And for an area, we need two different y values. We need the y start value, which is the y0, and we need a y end value, which is the y1. So here we specify first our y0, and this y0 is in D0. So we get this single data point, and then at the first element of our array, this should be the y0 value. And of course, here in that array, this is not the pixels value that we need for the screen. So we wrap that in our y-scale function so that we will get actual pixels here. And then we need to specify the same for the y1. And this is analogous to that, y-scale d1. So this will let us go to the browser. So here we go through each of these elements, through each of those, and then we grab the first as the y0, and the second as the y1 variable. So that is the path generator. And now we need to create a scalable vector graphic so that we can actually plot something to our screen. And we can store that in an SVG variable. And we can take our viz, which is the container element, and then we can append an SVG. So let's just have that. And let's go to our inspector. And you see that this is our viz target. And now we have created that SVG element here. And so with D3, we have imperatively changed our DOM now. This is also a point that many people don't like about D3 because you actually program the addition and removal and change of DOM elements in an imperative style rather than in a declarative style. But I will show you in the end how you could avoid that if you don't like it. And we have now this SVG, but if you might have seen here when I hover over SVG, it's just this little blue colored rectangle here on the left. That's not what we want. We wanted that size here, actually the same size as our viz target div. And that's why we can use this attribute function here and say, okay, the width of this SVG should be as large as the width variable content. And we do the same for the height. We just put the height in. And let's see what happens now. So here the SVG has now width and height attributes, and now you see that it has adopted the width and height of the viz target container. So now we have our SVG, and within such an SVG you can put all the different graphics elements like circles, rectangles, and so on, but also paths. So let's add the path or the different paths, actually, plural, to the SVG that hold our different areas of the chart. And that's now another pattern which is quite common in D3. So we say SVG, which is our parent SVG element, and we say select all, and then we say we select all the elements which are of the class path. Now you would say, well, there are no paths yet on our page. Yes, that is true, but this is exactly the so-called create, update, and remove pattern of D3. What we can do is we can say, okay, let's say there might be paths in the future, and now I want to bind data to them. And for the data, I just give it that stream array. So remember that stream was an array of these 10 different journals. And now that says, okay, in SVG, we should select all the paths, but there are no paths, but there are 10 elements bound to it. So these 10 different journals. So D3 is able now to create these 10 paths for you. And you tell D3 that by the join method, and you say you want to join a path for every missing path element here. And that basically should do the trick. And what you can see here is we have now the SVG and we have 10 different path elements. So they are empty right now, so there is nothing shown, of course, because we haven't specified anything. But we'll do that now. So we can now set some attributes on that path. Just will indent that you know it's belonging to the path element right now here. And we can use the attribute fill, which is the color fill, basically. And for all of this data, I can also give callbacks here. So for all of these 10 different journals here, run through that and store one of these journals with all the information here in the variable D. And then do the following. Go to our journals array where I have not only the journal identifiers, but also the journal names and the journal colors in. And then I say find. So find me the array. I can say here I have a journal within the journals array. And if that journal's ISSN, so this is this unique identifier, is equal to the key of my current journal, and the key is actually the journal ISSN, which is currently selected, then take me out that and access the color here. So that will give me the journal color basically. So let's have a look if something is happening here. So you see that nothing is happening here, but we see there are fill colors now assigned, and this is the different fill colors I set in that journals array before for all of the journals. So now I can say, okay, the paths are not drawn yet because I haven't told them the geometry. And to set the geometry of a path, there is an attribute which is called D. A lot of these today. This is by convention in JavaScript thing. And I can just take our path generator, and you remember our path generator was stored in the stack area variable. So I can just put that here, and D3 knows what to do because we bound to every path the certain entry of that stream array, which corresponds to this current journal. And then this is run through, this data information here is run through our path generator. And now we can go here. And exactly what we see here now is for all of the journals, we get one of these areas in a different color. And also the Y numbers are correct. So you see there are not that many publications in 2010. And then there is, like, for example, one journal here, the yellow one, which is popping up here around 2013, 14, and then getting very big. So this is actually now the path. And let's have a look about to that D attribute. So this is, for example, one of these paths, and here's the D attribute. And you can see that is actually the description of how that path should look like. And this is basically just an assembly of X, Y coordinates where all the corner points of this path are. If you want to know more about that, that is nothing special to D3. This is SVG syntax. Yeah, so this reflects now what we want to have, but actually it doesn't look that nice. So we have certain points where we can tweak that a little bit. One tip that I can give you is that often when you use fill colors, it's good to put some transparency on those, then they look a little bit smoother. So we can put another attribute to the path here, which is called the fill opacity. And we can set that, I don't know, to 0.8, for example. And then they look a little bit smoother. So what I don't like that much about that chart right now is, yeah, that we have this hard and yeah, these corners here. I want to have them a little bit more round, maybe. And this is something that the D3 path generator could handle for us, because the D3 path generator is generating that path, and we can give it some more arguments to smooth these lines a little bit. So let's go to the path generator, which is here. And then I can just add another method here, which is the curve method. And you can look that up. I always Google those. There are a lot of different curve shapes. There is, for example, one which is called D3 dot, to look it up, curve cardinal. And you can put some parameters. There is tension method, and let's just set it to 0 and see what happens here. And now we have very nice rounded areas, which looks much nicer now. So that is one possibility. There are a lot of more different possibilities. And if we go again to one of these path elements and have a look at the D attribute here, we see that this is now a little bit longer because it needs to describe now these smooth curves a little bit more. And when it comes to the stacked area, it maybe is also not that nice to have that common 0 y value here, so that you have this straight line here on bottom, but maybe it's nicer to really have a stream chart, because that is by definition only a stacked area chart, and a stream graph is still a little bit different. I will show you that. If we go to our stream, where we define how the data actually looks like and where these y0 and y1 positions are set, we can add a method here, and that is called, this is also something I always need to look up. I do this for years now, but you never learn all these different keywords. So here is an offset method, and you can set that to D3 stack offset silhouette, and that just changes the data structure so that we have now it's centered to the middle vertically here, which also makes it look very nicely. And yeah, now we can also add like axes to that. In interest of the time, I'm going to copy paste that, but you can have a look at that later in the GitHub repo, of course. The axis is another element that we just put to the SVG. Let's see if that works. Yeah, so this is just putting an x-axis here. So basically everything that you can draw on a piece of paper is possible in D3. And this is now our final visualization. So with that, we have visualized the number of papers in SciLife top 10 journals. In color, we have the different journals. Of course, a legend would be nice. I have a little bit, I took a little bit more time in the preparation of this talk and put the legend on it, and also changed a little bit the appearance, which you can see here. This is basically built on that what we did today, and this is also in the GitHub repo if you want to have a look how that works. So, but here I have added a legend, so which journals those are. And for example, this yellow one is Scientific Reports. So here we also get a nice tooltip for easy reference. And what I did here, the most striking change, of course, is I merged a so-called bump chart into that stream graph. And a bump chart basically is just a chart where you order your lines by their rank. So here, at every time point, the journal with the most publications is on top, and then you get it sorted down to the journal with the least publications, and that makes it also visually very attractive. And this is just some more lines of code in JavaScript to tweak that stream data generation function. So you can see here everything is really possible that you might imagine, and you can think about adding here a y-axis and so on and so on. So usually you have to come to an end at some point in database. There's always more to do. That would be an example of how you would take data, use scales, use the path generating function, use data transformation functions, and then finally to put it with D3 in your browser. And now, as we did that, the question is that the future, how data will be? I always told you that, or I already told you that it might be not the best coding style to do it imperatively. So to really program, put this in my SVG, because that's hard to read, it's hard to reproduce. So this is not really the future. The future, in my opinion at least, is to use some front-end framework. For example, Svelte, which is one of the newer ones, which I really like. Maybe you already know React, or you maybe already know Vue or Angular. That goes in the same or similar direction. Svelte is a little bit different because it's very lightweight. It's very easy to learn, and you can just Google Svelte. I think svelte.dev is their homepage. And with that, you can write the DOM operations, so that you add like a path and you add like an SVG. You can declaratively write that as HTML and then add your D3 scales on top, which is very nice. I also have a talk about that. If you go to the GitHub, you'll see that. So that's it basically. So you will find today's code here in that GitHub repository. And you can also check out more projects on my website, higsh.com. They are all made with D3 and they are all open source. And you can have a look how I did that and what all the programming paradigms are. So in my opinion, learning D3 is best by learning by doing. All right, so that's it from my side, and I'm happy to take questions. Yeah. I think the best way is really learning by doing it or looking how others did it. And there I can recommend a website which is called Observable. And that is also developed by the creator of D3, by Mike Bostock. And there are thousands of tutorials, or not thousands, there are hundreds of tutorials and thousands of examples how to build different stuff with D3. So I would really recommend to go to Observable. I think it's observablehq.com. And yeah, they have tutorials, but also a lot of examples.
We've got a question in comparison with Python, in that D3 appears to be too low level. Would you point people in munging their data in such a way that it's compatible with D3 and then just plotting that directly? Or would you have people process the data separately so that it's compatible with D3 and then doing as straight path as possible?
Mm-hmm. Yeah, I think most often it's easier to prepare your data in your data science tool of choice in Python or whatever to have it ready for D3, because you have to keep in mind that D3, everything you program in D3 is running in a browser, so the computational resources are quite limited in the end. So I would recommend to not use D3 for exploratory data analysis, but more for your final product, basically what you want to show to others, because it's quite an effort to build such a visualization. And I think it's too much an effort for exploratory data analysis, but rather use it for the final product. And there you, I think, then have the chance to bring your data into the right format that is easily interpretable by D3 before.
Are there libraries on top of D3 that you would recommend that people start with that might make this a bit easier?
Yeah, there are a lot of libraries on top. So one which is a little bit more high level than D3 is Vega or Vega Lite. And then if you want to go even more high level, there is, for example, HighCharts or Plotly. So these are two libraries I would recommend if you want to very easily plot something. So if you have like a chart that is a common chart, like if you have only a scatter plot to do, then you can use HighCharts, and they have a scatter plot function where you just put in your X, Y values and your legend, and then there is some magic under the hood which is producing your scatter plot with D3 in the end. But you don't have to deal with all these screen pixels and scales and so on.
And a final question, perhaps, is D3 seems to be closely tied to SVG. Are you able to plot to, say, Canvas?
Yeah. Yes. So D3 comes with support for Canvas too. So, for example, these path generators, they can take a Canvas context and then plot automatically to the canvas. Otherwise, when you have more complex assemblies where you use Canvas, you would draw on the canvas directly by the drawing functions that Canvas comes with, and just use the D3 scales, for example, to calculate your scales, and not use the path generator. But for most applications, you can use the inbuilt context method of the path generators. And it's also possible to use WebGL, for example, together with D3, because D3 is so low level that you can say, okay, I'm just using parts of it, like the scales or interpolations or things like that, and then do the actual plotting in WebGL or Canvas.
Okay, fantastic. Thank you very much for your time, Matthias.
Yeah.
And everyone who's watching, thank you very much for coming. Just so you know, we've got the Belgian Research Software Engineers Association is putting on a conference at the beginning of December. You can check that out at our website. We'd be very happy for you to come. It's an online conference and free. And we'll be back again next month with another talk, so I look forward to seeing you all there. Again, thank you very much, Matthias.
Yeah, thanks for the opportunity.
Thanks for your time. And everyone, goodbye.
Bye.